Hi.
Our presentation, title of presentation is The Experiences of Preservist Math Teachers with a Model Eliciting Activity using a digital tool and 3D printing. I'm Yurda Gül from Maltepe University, Turkey. And Guillermo, Matias, and Professor Lavitsa are from JKU. Actually, I'm here as a postdoctoral researcher, and my supervisor is Professor Lavitsa. I came here through the grant of International Postdoctoral Research Program from Scientific and Technological Research Council of Turkey, TÜBİTAK. I will present here part of my postdoctoral research. First of all, I want to talk very briefly about my postdoctoral research. It's design-based research, and it has mainly three phases: preparation, design experiment about classroom implementation, and retrospective analysis analyzing all data. For the second phase, design experiment phase, I had 2 macrocycles, and for this study, the present study that I'm presenting now is part of, is the first implementation, first activity implementation of the first macrocycle of the design experiment phase. We implemented a model eliciting activity to Preservist Math teachers here in one session of 3D printing in school course. Matias was the instructor. Let me talk about model eliciting, model building activities. They are open-ended problems to make mathematical models by collaborating with group mates to build a stronger model. They may involve optimizing some outcomes, and here we use optimization as finding the best way to do something. And also we use model eliciting activities using digital tools. That is, your mathematical model is technology-based representation, very briefly. What is needed from literature? We know that Preservist Math teachers need to be provided some opportunities using digital tools and 3D printing technology, so that they realize, they understand the benefits of these environments. And also in the literature, using 2-dimensional geometry for the 3D printing technology, there is little information about it. So by combining these perspectives, actually we had 2 main aims. The first aim is to investigate the experiences of Preservist teachers with model eliciting, with mathematical modeling using digital tool, 3D printing technology, and 2-dimensional geometry concepts by using these concepts. For the second aim, we decided to evaluate this model eliciting activity. For description of the learning environment, this course, 3D printing in school course, is a basic course on 3D printing. And before our implementation, we implemented it at the very beginning of the semester, last semester. The basics of how printers works and something like that was explained before our implementation. This session was the first for using 3D printing technology within mathematical modeling context. Am I right? Okay. And our implementation had three main phases. First of them, we explained what mathematical modeling is, modeling processes and modeling with digital tools to the pre-service math teachers. And then we introduced the activity to them. The activity was about packaging context. They formed their groups. They had at most 4 members for one group, and their group work. They created 2D or 3D models using a digital tool and used 3D printing technology in this session. And also we had 5 mathematics educators during the session to guide the participants. Thank you to all of them. This is the activity. I want to summarize the activity very briefly. This is for using 2-dimensional geometry mainly. You have a rectangular base tray. There is a cake inside it, and you want to serve it using different polygons, shapes, like rectangle, rhombus, isosceles triangle, and square. We gave particular dimensions and also price of each portion. Here, the aim was to create a mathematical model using a digital tool to get 3D printing of their model that provides the most profit from one tray of cake. For this activity, they might create different models using any digital tool, whatever they want, and they choose the best one. Here, actually, I mean, process was important also, not only the result. I mean, their models. We had 20 pre-service math teachers. One of them participated individually online, and all others worked in groups. We had 2 groups with 2 members, 3 members, and 4 members. And all for data collection tools, we have questions before the intervention, reflection questions asked right after the implementations, and we had interviews, field notes, screen and video recordings. For data analysis, it's qualitative research. We transcribe data to verbal interpretations. Here, I will present some general results. I don't want to go in details, actually. Along with our aims, we divided our findings into 2 parts. First part is about their experiences, and the second part is about evaluating the activity itself. For their experiences, we had their ideas, difficulties about the activity, modeling, group work, using their mathematical model and mathematical knowledge and digital knowledge, and how they solved these difficulties. First, they try to understand the activity itself, what to do, something like that. And they ask questions in this process as well. Most of them started to solve the activity by using paper and pencil work, actually. And then they started to use a digital tool. Just one group used Blender software, and all other groups used GeoGebra software. For mathematical knowledge, they use different kinds of knowledge, actually, not just the 2-dimensional geometry, like 2-dimensional geometry, 3-dimensional geometry, theorems, Pythagorean theorem, coordinate plane, scaling, transition from 2D to 3D, making calculations and functions like that. They use different kinds of mathematical knowledge, and those are pictures from their paper and pencil work. For digital knowledge, they used, we can say that they used the knowledge about using that particular characteristics of that particular digital tool to create their model. We observed that I think they seemed that they were aware of capabilities and limitations of this digital tool, and which is very important, I think. And they carrying out steps of 3D printing processes during the class. Improving this part is, I think, important for 3D printing technology, improving their model to meet the 3D printing technologies affordances. It was a two-dimensional model, and in order to get 3D print, they needed to add walls between two shapes, and they needed to switch from 2D shapes to 3D shapes, considering their thickness. I think they used both their mathematical knowledge and digital knowledge together. Those are some pictures from the implementation. Let me show them one by one. They asked many questions to Matthias and Guillermo and all others. Selen was one of the, thank you, Selen. At the end, they tried to get 3D print. Actually, they were observing it. Those are some examples. Some of them had both 2D and 3D models at the same time. And those are pictures from their screen, their work. Actually, all groups wanted to use 3D printing technology, but because of the time issue, just 2 groups wanted to have a 3D print, and also not the whole model. Just they wanted to take a 3D print of just one shape, like triangle. They scaled actually their model because of the time issue. They asked so many questions during the session. They asked questions to understand the requirements of the activity. It was important. They asked questions to decide what the digital tool to use for modeling, to improve the model to meet 3D printing technologies affordances, to understand the processes of getting 3D printing of the digital model. And also, they were preservist math teachers, but they asked many questions about how to work in a group, how to ask questions to each other and to the instructor. It was important also, I think. For the group work, I think they seemed that they understood the benefits of group work because they thought that they complemented each other, helped each other, needed each other to complete the model. And also they tried to solve the difficulties by asking questions to each other, to their group mates, to other participants from other groups, and to the instructor. For conclusion, we may conclude that such environment may be beneficial for teachers, because they may understand, we can conclude that they, to some extent, of course, they understand the benefits of such environment. During one interview, one student said something, we use something, and then because we are going to be teachers, they are aware of their the importance of such activities for their future careers. For findings about evaluation of the activity, this was two-dimensional activity. Actually, they didn't see the use of such two-dimensional problem within 3D printing technology environment. So as a math educators and teachers, we should be careful about designing an activity that involves two-dimensional geometry within 3D printing technology. And at the end, I have some lessons as a researcher. After this was part of design-based research, so I considered some lessons I got from this implementation for my further study. I don't want to talk about them in detail. I think one of the most important thing, some groups had 4 members. They needed to create just one model at the same time using one computer. So having 4 members within a group to create one model by using one computer was not functional. I advise to use 2 or 3 members within a group. Then these are references, and thank you for your attendance and patience.
Okay, wonderful presentations. We have like 2 minutes for questions, please. Yes.
Thank you for the talk. Maybe not a question, but a comment. I really liked your exercise, and I think it would be perfect for a laser cutter. Yes, so if you, because then you have a 2D dimensional, so and it's fast. So I think it would be perfect. You should try it.
Thank you for your suggestion.
Thank you for the comment. Any other comment or questions? No? No, if no, thank you, Rico.
Thank
Thank
you.
you so much. Now I would like to invite the second presenter. We also have Aida Hatis and Prof. Suklafiksa.
Is it okay?
Yeah.
Hello, everyone. I'm here to tell you something about that we do with Professor Scholz. The title is How Can We Integrate 3D Printing Technology into Teacher Noticing? Yes, we saw lots of presentations about 3D, and it was all about applications of 3D. This will be not an application of 3D presentation because I'm a beginner in 3D printing. So this was about how the research that I plan to do in the future. And yesterday, where is the Indonesian colleges? Yeah, you said that you have one 3D printer. Yeah, before I came here, I asked my university that whether we have any printer, 3D printer or not. They said yes, we have one, but it was broken. So I think I need more this 3D printer. Support me. You can give tickets. Oh, it's okay. Yeah, I'm here on behalf of Gazi University in Ankara. This is Ankara, lots of building. Yeah, did you ever come Ankara? No. Yeah, Okay, and this is my university, Gazi University, from the high point of view. Everyone knows Professor Scholt,
Yeah, that's right.
so I won't tell about him. I will tell about myself. Let me introduce myself. I completed my PhD on mathematics education in Gazi University. I was studied on especially those three areas: noticing abilities of mathematics teachers. This was the research area of my thesis. Geometrical reasoning. This is my special interest, nature and philosophy of mathematics. Now, technology. I will tell about noticing abilities later, but I will say that I used diagnostic competency for these abilities. Noticing is about teacher abilities to understand students' thinking, their students' thinking. But I inspired from German scholars the same meaning. They say diagnostic competencies. So I used these diagnostic competencies instead of noticing in my thesis. Then I am interested in geometrical reasoning. Particular geometric is different. Yeah, I wonder that students maybe think different ways of geometry. I consisted my studies on with GeoGebra, and yeah, this is my love. Nature of mathematics, philosophy of mathematics. I was far away from technology since still, okay, because of philosophy, I think. Because mathematics is more than practical ways, in my opinion. STEM and technologies are, yeah, so practical for me. Yeah, I see those areas in a pragmatic way. But I think mathematics is more than this pragmatic way. Yeah, I see mathematics from the point of view of Platonic way, I think. So I was far away. Yeah, no. Is there any technology? No, I'm not there. But now I'm step by step technology. So I am new. Yeah, what is noticing? Classrooms, yeah, we know are busy. Lots of activity. Teacher had to get attention. They must carefully select what to prioritize and what to overlook, as well as interpret. And this cognitive effort is termed teacher noticing. Teacher noticing encompasses 2 aspects: observe, teachers choose to observe, and how they interpret what they see. Consider this example. A teacher notices a student with her head down on her desk. One teacher might interpret this as laziness, focusing on the student's posture and drawing conclusions about her engagement. Another teacher might perceive the same situation differently, inferring that the student is simply in a need of break. When a teacher perceives a student as lazy for having her head down, it's probable that the teacher won't provide meaningful opportunities for that student to engage with the content. Conversely, if the teacher interprets the student's behavior as needing a break, she might offer alternative learning opportunities either later or in a different format. Yeah, you get the point, I think. I don't need to read all these again. Yeah, this example explains what noticing means in general terms. Of course, we can specialize it in the context of mathematics education. For example, a child cannot do addition. A teacher who interprets the situation as the student not having the capacity, and the teacher who tries to understand the reason will take different actions. So it is important. Yeah, noticing is important in the context of mathematics education. When we started working with Professor Scholt, how can we get a common research area? Talked about it, and I think about the technology and noticing, combining those ones. How? But the question is how. So we looked at the literature, technology in noticing literature, because we know that technology is everywhere. Students are familiar with technology, so teachers should notice the use of technology too, students' use of technology too. This was our motivation. In order for teachers to understand their students' thinking, the use of technology by students must also be noticed, yeah. Or we can use technologies to improve the teachers' noticing skills. Yeah, it can be in a two-way. We looked at technology in noticing literature, and we saw that research areas use videos and GeoGebra. Yeah, how they use videos to identify and enhance teachers' noticing skills. So we asked ourselves that which technologies can be used for noticing skills. Yeah, noticing skills can be improved by or in the following technologies. Yeah, you can add any technology like AR, VR, 3D pen. So we wonder whether we can integrate 3D printing or other technologies and into the noticing skills of mathematics teachers, and how. We looked at in the literature and we find a framework. Yeah, Bailey et al. Yeah, Bailey and his or her colleges. This is, I don't know the reading of it, NIT or NIT. Teacher noticing of students' work in a tool-mediated learning environment. You can see there were two phases of noticing: attending, remember, and interpreting, and finally deciding how to respond the student. So as you can see, there are two-way arrows here, two-way, and then the result. How the teacher will respond to the student is a result of joint evaluation of these components. Yeah, we interpreted this framework like this, and our approach can be maybe creating scenarios or problem-solving tasks that require students to apply mathematical principles through these technologies, and prepare tasks for teachers by observing how students approach and solve these challenges, focusing on the integration of the technology. And we asked ChatGPT, how can we do this? Yeah, it gives more example for me. I talked about only this one. It gives me more opinion. Yeah, as you can see, I asked it Should I say it for ChatGPT? I think, yeah, it. She? No, no she. Where is Eva? What should I say for ChatGPT? James. Okay, I call it and asked it, please detail. Yeah, what should I do for these ones? Oh, it's just that you can provide pre-training sessions for preparation, or you can familiarize teachers with common challenges and misconceptions students might face with 3D printing. Or it suggested that we can arrange observation sessions. We can encourage teachers to ask open-ended questions that prompt students to blah, blah, blah, blah. And it said that we can organize post-observation discussions or workshops. Yeah, very good suggestions. Foster a collaborative environment for teachers. Yeah, this one is my favorite. Provide case studies and resources showcasing successful implementations of 3D printing, but I can add unsuccessful implementations too. Share examples of teachers who have improved their noticing skills through similar innovations and feedback mechanism. Yeah, it's important to establish, a feedback mechanism where teachers can receive constructive feedback on their noticing skills and strategies and encourage peer observations. Thanks a lot.
Thank you so much, Aidance. Okay, it's time for questions or feedbacks.
Yeah.
Yes.
So I think it's an interesting aspect of how you look at 3D printing. But what do you mean by 3D printing? Is that the modeling? Is it the actual printing? Is it the reasoning behind it, or what is it?
We are arguing with my colleges. Yeah, this situation. I think modeling is important for us, for mathematics teachers. Yeah, I'm asking myself the question of when they print, what we do with the print? Yeah, we can compare the model and the real print, but the modeling is important for us to, I see 3D printing as a modeling process. Thank you.
Okay, thank you. Still have some time to have questions. Eva.
At least in the interviews that I did with teachers in Austria, they sometimes complain that it's really hard to have a collaborative environment. And so the question is, how can we achieve that?
Yeah. I don't know either. But we can figure it out. Yeah, I believe. But I don't have any answer yet.
Okay, Celine.
Thank you for the presentation. Teacher noticing is my PhD,
Mhm,
so I am
I
very
know.
interested in your presentation. You said that you asked ChatGPT how we can improve.
Mhm.
Okay, improve. It's my second question. How we can improve teacher noticing. But I'm wondering how ChatGPT define noticing. Did you also
Yeah.
ask James how he
James.
interpret it, how he
Yeah, yeah.
define it?
Yeah. I didn't ask, but I said that show me the noticing literature, and it summarized the noticing.
Because it might be confusing at some point. Recognizing something is not enough to say notice it.
Mhm, mhm.
Maybe we can ask first ChatGPT how he define
Yeah.
how James defines it. And my second question is, one of my presentation, a listener asked me, can you improve teacher noticing, or can we also support their ability of noticing? What do you think?
Oh, it's a hard question.
Yes.
What did you answer?
I will answer it after your replying.
Yeah, improve. Yeah, I think support is more meaningful. Yeah, maybe
She said
it's-
that we can never improve any teacher's ability, but we can only support them.
Mhm.
That's why I want to
Thank
ask you.
you.
I really don't know the exact
Different-
correct
yeah,
answer.
Yeah,
Mhm.
thanks a lot.
Thank you.
Thank you. Give very big round of applause for our second presenters. Okay, now let's move to the third presenter. We have something interesting related to jewelry. I'd like to invite Natalia Budinsky. Yes.
Hello, everyone. My name is Natalia Budinsky. Some of you might know me very well. For someone who don't know me yet, I'm happy to meet you here. And I'm math teacher, and focus of my research and my work is innovation in education. And I am dealing with teaching mathematics and STEM subject through art activities. And today I will be present one activity that was conducted in my school, where we were using 3D printers. It's a project called 3D printed jewelry inspired by mathematics. This is one of the possibility of how can 3D printing can be applied in mathematical lesson in order to develop jewelry which has art and ornaments that are inspired by mathematics. So students research and learn about mathematical concept from different aspects, from the aspect of art. Why should we use 3D printing, and why 3D printing is a very good activity for students? Because the final 3D object basically represent learning path that travels from abstract idea to a realistic, handful, and applicable product. Student has an opportunity to see their physical representation of their ideas and of some mathematical concept. So also we can connect those activities with art and artistic expressions. So it is more even interesting, and it can also attract students who are not that much involved in mathematics. There are several categories of, actually 6 categories of using 3D printing in education according to Ford and Minshall. It's about teaching students about 3D printing, teaching educators or teachers about 3D printing, supporting technology during teaching production or 3D printing of the artifacts that could help to learning process and to understand different mathematical and other STEM subject concepts, create assistive technologies, and support outreach activities. So there is a wide space for using 3D printing in education in the classroom and in general. So the main potential of 3D printing is that the authentic ideas of learning and teachers and of learning and where teachers are guides to the process, because this is the open, that are mostly the open task where students go from idea to the visual representation of the idea. So there are many things that can be also tackled beside mathematical concepts such as critical thinking, entrepreneurship activities, and so on. So these are some of the good practices, and 3D printing curriculums can integrate STEM and careers in technical education. So we have to think one step ahead, that when students finish their education, they might have find their future career in this field, which is very good field for building a career. Since there will be more and more demand on 3D printing object in the future. Also, we can also include coding and computing education, and also we can use 3D printing in social studies, also in humanities. So as I said, I will showcase today an application of 3D printing in my classroom, and I will talk about project that we applied with my students. There are several steps, so like pedagogical approach, learning outcomes, accessibility and equity, curriculum integration, assessment method, and long-term impact. That was the things and stages that we went through when we were applying this project in the classroom. So it is like very wide. That is an open project, and it had a wide impact on students, and not only in the classroom but also beyond the classroom. So the first step in this project was to explore different mathematical concepts that could be applied to the creation of the jewelry. So that is the connection to the curriculum. Students explore symmetrical patterns, fractal shapes, geometrical tessellation, mathematical theorems, and historical mathematical concepts, history of math puzzles, anything that could inspire them to produce final product, and that is a piece of jewelry. So in that way, they have had to deal with the mathematical concepts. So this part of covering mathematical curriculum and that what is required to do in the classroom was covered, and we didn't miss mathematics. Actually, we had a lot of mathematics during this process. The next step was when they choose the mathematical concept, they explore the mathematical concept and sketch design of their jewelry pieces, and then use this. We use several 3D modeling softwares for printing. This is one. This is an example. This is a screenshot of the student that was exploring and modeling in Tinkercad. We also use GeoGebra, and that are software that are easy to use in the classroom, and students really they really acquired those software very quickly. So that was the next step, and then they prepared the design for 3D printing. Before we 3D printed some of the object, piece of jewelry, we learned students learn about file formats, how to prepare resolution, how to turn on the 3D printer and so on, make settings for the printing. And then also this is the design of one 3D model in GeoGebra. It is also very useful and suitable for 3D printer. So after the students finished and obtained final project, they evaluated in a group work. We evaluated jewelry pieces from both mathematical and artistic perspective. So we analyzed the mathematics incorporated in the process, considering aesthetic qualities and reflected on the design process. We made a small exhibition where students showcased their products, and they explained why they choose some of their design, what was the mathematical concept behind the design, and how they get from the creative and how they connect creative and mathematical work. So it was one stimulated and collaborative environment, and students provided feedback to each other, and they were engaged in fruitful discussion about mathematics and art. So that really led to increasing understanding of mathematical disciplines, art, and also technology, because we use the new technology, 3D printer. This project was awarded at the competition, local competition for students' entrepreneurial idea with the third place. And also this project was awarded at a small competition about female entrepreneurship. So it has a good potential to become commercial in the future. So these are some of my examples that I apply in the school. Beside this project, we had visit the technological science technology park in Belgrade, which is the leading institution in Serbia, where the innovation in technology applied, and they are dealing with that topic. So students had an opportunity to talk to the companies that deal with 3D printing. They print different products. So also we were doing 3D printing as a career counseling, so maybe 3D printer as a future job. We printed different kind of objects like Lego bricks. So then we printed windmills, where we were dealing with sustainable environmental issues. This example where we connect mathematics, art, and entrepreneurships, and many other activities, since we have several 3D printers thanks to the generosity of the JKU. So my students have an opportunity to print and to explore and to make their ideas real objects. These are some of the references I was using during this the research, and that will be my story. Thank you.
Thank you so much, Natalia Budinsky. Actually, we still have 5 minutes. Okay, now it's time for questions, feedback, comments. Please. Okay. It's on already.
Thank you. How the students or how do you decide on the mathematical content that are bringing into this jewelry creation?
In this project, it was open to them. So yeah, so for example, what we have learned so far can be a base for the mathematical inspiration. So, but it can be narrowed to some topic, like complex number jewelry inspired 3D printed or something like that. Since I mean this artistic component, and when we put this constraints like complex number, or I don't know, Euclidean geometry, so it should even provoke more artistic, more fruitful artistic results. So yeah.
Great, thank you.
More questions? Yes.
Thank you very much, Natalia. And it's nice to see you in person because I've seen you online before now. My questions are very practical. There's two. First of all, how old were the students? And secondly, how much lesson time or how much school time did it take?
Students are was like 15 years old. So it's upper primary or lower secondary, still depends on the curriculum. And it was not just one lesson because it was a project based, so we had also like after school activities and so on. So but in for example, it was like maybe 1 month for like 2-3 lessons per week.
Right. Thank you very much. Thank you.
More questions? I have one actually because it is related to jewelry. Like I think I can have a gender stereotype with jewelry. It is for females. How your male students experience that?
Well, actually, that is also one the topic maybe I should could mention in the presentation, that we have also many projects in our school that work on supporting actually girls to get more in technology and STEM activities. But there was, I didn't notice any problems because it is like math inspired jewelry, so it's basically a men's field, so it was like a good combination of also activities that could employ also girls and boys equally.
Okay, thank you. Rova. Online questions? Okay.
From Brigitte to Natalia. What did students consider as good mathematically and aesthetically? Examples, what they said. Do you have any examples of what they were discussing about?
Well, I mean, these are quite young students, 14 years old, so they are not that much in mathematics. So we were discussing like basic mathematical contents like geometry. For example, triangle can be a good idea for some pendant, or maybe you saw the infinity signs. So where they were learning about infinity sign, for example, when they are solving equation, then they have to put the solution in some interval on one side can be. So that's kind of things that we were discussing mathematically and then somehow connected to art.
Thank you.
Okay, thank you. Okay, thank you, Natalia. Give a very big round of applause. Now it's time for coffee breaks. As usual, you can go there to enjoy the coffee and the snacks for 10 minutes. Yes. And I would like to announce also that the certificate is ready in that tables. You may take it. Thank you. You put on this
Is it necessary?
because the online can hear it.
Maybe they don't need.
Okay, everyone, we will shortly start the next presenters. So the next presenter will be about demands for the representations, transformations throughout 3D modeling with GeoGebra, construction of Taj Mahal. We have Celine Galik, Matias Tehera Urhan, Arkun, and Prof. Lafixa. So Celine, are you ready?
I think so.
Okay, the floor is yours. You have 15 minutes.
Okay, thank you. So let's start. In this presentation, I will try to show you and present using and transforming some multiple representation during the 3D modeling process of Taj Mahal on GeoGebra. But first of all, I would like to introduce our team. My name is Selen. I'm a PhD student in Turkey. I am the presenter of this presentation, but there are lots of names behind the study. All of you know Matias. Maybe we can call him the superhero of 3D printing and modeling. If you want to ask any question 3D modeling, please let us him. Dr. Selin Urhan, maybe I can say she is the milestone of my PhD career. She is the best person I have ever met in the field of mathematics education. If you want to study in argumentation or technology, please talk to her. But I don't want to share her with you. And Professor Scholl and Professor Selay are our angels, and a big thank for them. Let me summarize our motivation for this paper. First of all, we have a video, and this video shows us, yes, he's our expert. In this video, we can investigate or examine all of the process, how we can modeling Taj Mahal on GeoGebra. When we were trying to watching this video, we noticed something. I know noticing is my focusing topic, but I want to don't want to mention about it right now. We noticed something very important for the modeling process, which is he used lots of multiple representation and transforming this representation. And we ask ourselves, how or does 3D modeling process can provide or enhance the students to use multiple representation during the modeling process? And we decided to examine this part. So our aim is to examine the using and transferring representation or register during the 3D modeling of Taj Mahal on GeoGebra by a GeoGebra expert. I know all of you know Taj Mahal, but how it looks like. And if you want to see our modeling, you can observe it. In the field of mathematics, there are lots of various ways to represent a concept, and we call them multiple representation. And these representations are verbal, numeric, algebraic, and blah, blah, blah. For the student, conceptual understanding of a mathematical concept can be explained by their knowledge of using a representation and transforming among them. So it is really important, highly important for mathematics education, not only mathematics, but also the geometrical concept. It is most important part for us to use and transforming them. Okay. And that's why we want to analyze and investigate this process. You can see our methodology part in this slide. We first start with collecting videos with our expert and watch all of the videos again and again to analyze each step during the modeling process and understand what kind of or which kind of presentation he used. We investigate he used three different representation: algebraic, 3D graphic, and 2D graphic and 3D geometrical representation. Actually, in GeoGebra, we can use lots of representation or view, but in this field, in this subject, to construct the Taj Mahal on GeoGebra, our experts choose and use three of them. And then we compare the use of this representation, analyze, reviewing and revise our analysis again and again. To represent our data, we use matplotlib library in Python. Each row represents one representation like algebra and the others. The red color represents the view or representation is open and our expert is use it actively. In the yellow part, it represents the view is open, but our expert didn't use it actively. We can only see the view. In the gray part, he closed the view completely and nothing in that part. All of the modeling part took approximately 10 hours. Since it is not fit entire the present all of the modeling process, we only focus and analyze the first 10 minutes for this presentation. Okay. He starts with algebra and 2D graphic view. You can see here, there is not anything in the 3D geometric part. He used the GeoGebra command to create some points on algebra view and construct these views in 3D graphic view. So we can say that there is some transformation with, from algebraic part to 3D graphic here. And then he continued with the 3D view only. He closed algebraic one and create a polygon by using the polygon tool on GeoGebra. And then he also creates some equivalent for circles, you can see here. And these points, which he created before in algebraic view. Actually, it's another transformation, not between, but within and present representation. At some point, there are some gaps. You can see there is not any red part. So the view is open, but he never used it actively. In this part, he never used completely. In this part, he closed the view. He was doing something in this part, but we didn't know what he wanted to do. So we assume that maybe he think what he wants to do in the next part, but we don't know for that. And then he continued with the 3D graphic view and construct some, he continued with the 3D, yes, not 2D, 3D geometric part to construct some prisms by using the polygons and the circles. He created this rectangular prism by using the rectangular polygon and the cylinders based on the circles he created before. In this part, he continued with the algebraic view and select some of the commands to change the thickness of the border, the height of the prisms or cylinders, and the colors of the objects. We can say that it's a designing or aesthetic part of the modeling. Maybe it's a transformation, but a cognitive aspect we want to investigate. The most important part was that you can see at some point, even if they were too short, he used three different representations together. He creates some points by using commands on GeoGebra algebraic view. He commands a point and he creates some points in 2D and 3D views. So it's a good opportunity to see how they can there is a connection between the other multiple representations. Okay. According to Duval is the father of the theory of semiotic representation and they base our paper. He says that the student's performance to transform one representation into the other one is highly crucial for the field of mathematics education. And in this study, we can indicate the 3D modeling process of Taj Mahal, because in our case, we only investigated the Taj Mahal project on GeoGebra. Students enables using or transferring some kind of multiple representation, which are algebraic, 2D graphic, and 3D geometric representation. And it also gives some opportunity for conceptual understanding of a mathematical object for our students. In the next part, I mentioned before, we only analyze the first 10 minutes. So we should analyze all of the process and understand all of the combination and connection, multiple representation. And also we have a 3D modeling for the Taj Mahal. We can investigate the relationship or the connection between modeling and 3D printing. And I show you some gaps here. There were some gaps and we don't know what he wants to do in this part. So maybe for the future studies, the students or the users, maybe experts, way of thinking during modeling activity can be investigated. Here are the references. Before starting my words, I want to say thank you, Guillermo and Marjorie, to helping us for all of the process. And thank you for listening to me. If you have any questions, please ask us. Thank you.
Thank you, Celine. And actually, we still have 6 more minutes for your presentation. We already have one question here.
Hello, thank you for your presentation. I have only one question. It is about the way of thinking. How can you analyze that? How the students think about during the modeling?
Actually, in the literature, there are some evidence how we can analyze this process. The students are working collaboratively in a group, and they are talking with each other. They are saying, we have to do this, no, we have to do this, and something like that. Maybe we can say it's a discussion part or an argumentation part.
Oh, it's different.
The researchers are analyzing their words or sentence to understand how they are thinking.
Because it's not so easy to analyze the way they're thinking.
It's really hard to understand and define,
Okay,
but it is an example of how we can do that in the literature.
okay, thank you.
Another questions?
We also have the model, the expert.
Yeah, the one who created.
Yeah. For the ethical issue, I don't want to say he's our expert.
Maybe I went to the toilet.
She answered already in the gap. I was about to ask about that.
Let me say something. During the analyzing part, we say there is some games. I think he want to think what he wants to next, but Professor Silay says no. He got to toilet. So she's like,
Yeah.
10 hours.
So maybe this is a comment from me. When you record the screen or the process, maybe you can also record the face of the creator. So when he is not present in the screen, you know that he is not thinking. So he is living somewhere.
and also we want to collect their voice, what they are.
Yeah.
thinking.
Yeah.
This is
The
important to understand.
process would be
That will be
really add something contributed next time.
next time.
Yeah.
When is the next project?
I think the difficult part of the recording is it takes a lot of memory. So I had to cut. So maybe the blank is the cut part because I have to save and then save in the cloud and then record again. So it takes a lot of memory.
Yeah, maybe design simpler things so will not record long times. 10 hours is long. Okay, more questions?
Eva.
Eva.
Is there any question?
I was thinking if you would
Online.
screen share
Online.
with Zoom, then it would record your face and also your screen, and you can just save it in the cloud. Maybe that could be an idea. Yes.
You don't need
No?
No,
it's just.
Okay, next time to.
I think for the recording on Google Meet, we have to a premium account for it, right? We cannot record this.
The one of my university, but also with.
That's why you can record because We need a premium account to record in a Google.
Okay. Thank you, Celine. Give a very big round of applause to her. Now we have our last presenter for today, and we have Malika and the teams, Ertan Arkund, and it is about the use of 3D modeling and printing technologies in solving mathematical problems and its reflections on learners' computational thinking. So, moment, I need the clip on. Celine? Oh, okay.
I really like this one. May I take?
What?
I can give it to you if you can give me it.
You will receive 2 tickets. And this is, please put on your.
Okay. Hello everyone, I am Melike. I am PhD student at Hacettepe University in Turkey. And also I am work in JKU and I am happy to be here. And for this study, Kübra, Selay and I work together. Our study is on using of technologies in. Oh, sorry. Sorry, online. Okay. Our study is using of 3D modeling technologies in solving mathematical problems and its reflections on learners' computational thinkings. And 3D modeling and printing technologies encourage students to find unique solutions to solve attending problems. And play a crucial role in helping learners concrete mathematical concepts and increase their interests, and contribute to the development of 21st century skills such as critical thinking, creativity, and technologies, literature, and problem solving, and provide students with the opportunity to develop their computational thinking, which lies at the center of 21st century skills. Oops. Right, okay. And this study aimed to explore the reflections of using 3D modeling technologies in mathematical problem solving process on learners' computational thinking skills. For this purpose, we use the learners activity that involves the integration of 3D modeling. The activity was designed to solve a mathematical problem that we developed. And we use the Tinkerlad method. The purpose of the Tinkerlad method is to reveal the cognitive process and thought that emerge during an activity. Firstly, we create a learning activity that involves a scenario about a mathematical problem and ratio and proportion. We implemented this on 3 70th grade students. Before the implementation, we conducted one-on-one lessons to teach how to use Tinkercad for 3D modeling. To collect data, we use Tinkerlad method, students' worksheet and their designs on Tinkercad. To analyze data, we use the computational thinking skills evaluation rubrics. It includes the computational thinking components such as the abstraction, the composition, algorithmic design, data organization, and pattern recognition. Oops. For the learning activity, we used idea of candle clock from ancient times. This clock works on the principle that the nails on it fall when the candle melts. This is our scenario. The students designed the candle clock according to given problem. And these are the questions that we give them. A, B, and C are related with the mathematical representation of the candle's burning rate over time. E and F are related with solutions regarding the position of the markers used in the time burning of the candle. And the last one is related with 3D modeling of candle burning over time. This is a rubric which include the computational thinking components. We analyze students' answers using this rubric. The reflections of the mathematical mathematical solutions of the time-dependent burning process of the candle on the CT components are as in the table. Although each student used different algorithmic design and went through different abstraction process, they all reached the same mathematical result. In same cognitive process, two components merge. For example, data organized and abstraction. And these are different algorithmic designed by students while solving the problem. And this table shows the computational components related with the second problem, related with the placing markers on candle. In the solutions regarding the position of the markers used in the candle's time-dependent burning, the abstraction competency of student 3 is greater than that of student 1 and student 2. Therefore, student 3 solved the question correctly. Student 1 and 2 couldn't make correct association during the abstraction process. These are students' examples. This student didn't put the last marker. There is. Because she didn't realize how we understand that time is over. Oops. This table shows the result on the 3D modeling of the mathematical problem. Although they obtained the same result in their mathematical solutions, 3 different designs emerged during the 3D modeling process of the time-dependent burning candle. Now I will show you that models. All students choose cylinder shapes for the candle and conic shapes for the marker. These students determine the positions of the markers based on their heights above the ground. This is about pattern recognition. This student put the marker at the end of the candle. It showed made a correct association, but she also put the extra marker very beginning, which was not correct. So we can say that she partly went through the abstraction step. And this one is the correct example. She put a part under the candle, so that is the wood to make a noise when the last marker fell. This shows us she used a different algorithmic design, pattern recognition, and abstraction than the other students. To sum up, all students designed the time-dependent burning of the candle with different algorithmics in solving the mathematical problem, and they reach the same pattern in the process of the solving mathematical problems. Students students reflect all components of the computational thinking. The reflection of the decomposition and pattern recognition components were the same for all the three students. In the solutions regarding the position of the marker used the candles, time-dependent burning, students carry out their solutions based on the different levels of abstraction capacity. Only one student reached the correct solution. And actually, the research show that although students pursue similar mathematical solutions, they develop a wide variety of innovative representations during the 3D design process. It can be concluded that 3D modeling tools encourage students' creativity and allow them to understand mathematical concepts from different perspectives. And thank you for listening.
Thank you, Malika. So it's time for questions or feedback, comments, please. No, we should have. Okay, maybe one small questions from me. You also, yeah. Meanwhile, you are here. So you work also on computational thinking. I'm working on computational thinking, and you include all of the city components. I mean, like, do you think in all other lessons we should accommodate all of those all components, or it is okay to have just algorithmic thinking or abstraction only? In your case, all there, but maybe the compositions or the proportions are not equal. Maybe the biggest part is on the which one. And another question is, you work on the 3D printing. So did the student print it yet, or yeah, not yet?
No, because we haven't not 3D printing. Then it's just designed and we finished this work.
Okay, thank you.
For the first,
For the first questions?
I don't understand exactly. You say actually no, because we select these rubrics for specifically prepare mathematical problem solving this CT components, and the study shows the components. Every mathematical problem shows all components. But I don't know. These components, our study shows this person.
But in some cases, actually, it was difficult also to really differentiate.
Yes.
In some places, they really merged.
Yes,
So
because
that's why we merged some of the table.
Yeah.
yes, because this abstraction and data organizations, we not separate this cognitive process. And this process, no, nerede? Yer birleştirdim, yeri bulamadım. And this abstraction and algorithmic design and merge. We not separate this cognitive process.
Okay. Thank you, Malika. Good
Yeah.
work. Questions? We still have time. Comments? Matthias? No. Okay, give a very big applause to Malika. Thank you so much for attending these sessions. And this is the end of the session. Cecilia, you have housekeeping announcements?
Now you need to
Claim your tickets, 2 tickets for you, and for all the presenters, and the participants are getting 1, so I will be there with the white points. You can, but you are getting 2 also because you present, and another one to be here.